Hello. Hello, hello. All right. Um, so I'm gonna continue working on the cast language here. I was working a little bit off stream, starting to write a self-hosted cast. Last time I was trying to instead turn minicast into the full cast, but I think it's different enough that we can just rewrite it from scratch instead. Yeah. How about that? How about we rewrite it from scratch? So right now it doesn't compile because I was working on some things, but I basically have the REPL now, which is the interpreter, and the empty line evaluates to unit. I think that's all that I have right now. And like the parentheses are, yeah, I just have a non-exhaustive pattern match over here. Yeah, but what I was making here is introducing the compiler scopes, right? Which means that at compile time, the names, hello plus, are going to refer either to a binding to a runtime value or it's going to be a constant value. And speaking about constant values, I think actually I just had a thought that constants should not be values but should be places instead. Because a constant is a value that's known at compile time, but it still needs to live somewhere. So the name is a reference to the value, which is the place, not the value itself, basically. Which will make it easier for me to create the transpiler, or like compiler actually. Because in the Bootstrap, I have a map from value, basically like a set of values that have already been converted to the target, which means that I need to be able to compare the values. But in this case, I actually don't, because it's all I need is the ID. You know what I mean? All right. So let's work on that. Place. And place is a thing which has the actual, well, I guess place has the state, which is a place state, and place state is either uninitialized or occupied with the value or moved out. All right. That's what we're going to have eventually. So now I have at compile time, we have the scopes, and a local is either a binding to a runtime value or a constant value living in this place. There you go. And so what I can have is I can have the ID. I never even had the ID. Interesting. So something like that. I need an ID generator, to generate the IDs. Might as well just initialize this in the main. Somewhere around here. Place JS. Wait, what? Did I just literally import a file called JS instead of KS? Nice. And this should not be a fatal error. But it's okay, that's the bootstrap. Couldn't find ID in scope. Okay, so this should depend on the ID. Alright, so binding. We know what a place is, right? Now what's a binding? Binding will also have ID. It will have the type. I don't know, there was something else, but let's just have that for now. Expect a generic option T. Ord map is unknown. Common. Use std collections ord map. Field type is not there. All right, so yeah, there you go. So now when I look up a thing, this is any expression, right? So yeah, what I'm trying to do is to just have the variables, basically implement variables, and we implement constants too at the same time. So we have a constant place, and in this case, so maybe a place should have a type, right? Yeah, place should have a type. Place, like it has the value, but the value is actually optional because it can be moved out, right? So place should have a type. Yeah, let's do that. So we have an expression which is a constant, and the constant expression should have a place, not a value inside, actually, right? So we have expression shape, which should be a constant place. Sure. Field type is not there. So the type of this is place. Oh yeah, I know. My incremental compilation is not very good with includes, only with imports. Okay, and then this over here does not work because panic is actually not correct. Let's see, what am I doing here? I'm trying to look up a variable named name in the scope, right? So I'm trying to find it in the locals of the thing, or I'm trying to find it in the parent, and if it's not found in either, then this should do a diagnostic, I guess. So let's see, diagnostic. Report and unwind. Severity error. Source is compiler. Span. So I need to know where am I looking for this. Span. Lookup name, span. So I have span, and the message is going to be so something like could not find. Is there something like print escaped? String escape. Yeah, there is string escape content. Could not find. String escape name in scope. And that is my error that we report. Could not find span. Okay. So I need spans. I will also need the output and diagnostic. Any expression. So this returns an expression, either a place expression or expression or a value expression, I guess. Let's see. And this is defined over here, but it should instead be defined in the common, I guess. In this place. Alright. Row infinite failure. Binding or temp is not place expression shape. Alright, so I have place expression, which is only a temporary, right? But I need so I need a new kind of a place expression, which is a binding to a runtime variable. So they should just have the binding inside. All right, and what is this? Core syntax. Why don't you sleep? Morning. Because I'm fixing my sleeping schedule, so I just don't sleep, and then I will sleep, and then it goes to normal, you know. That's what we are doing sometimes. Right, so I wanted to have the core, which has the syntax. There we go, there we go, there we go, there we go. Let's use import core. Maybe it should be named something else. This is a cruel way to fix sleep schedule. It is what it is. Okay, core init should be a function that returns syntax. It's like core syntax. I think I should name it call syntax, and it's gonna be like T. And it's not core syntax T, it is a map. So it's like core syntax map. Yeah, how about that? It's a map from the name of the syntax to the specific core syntax. I'm going to call this core syntax. Core syntax. No impl of type underscore as module. What do you mean? Oh, I think it's because of the wrong priorities on the type expression. I need to put this in parentheses, and it's fine then. I need to fix that eventually. Alright, so now I just need to initialize the core syntax. This needs to return the map, right? So map is ord map new. That's a mutable map. And then I say, let's just say that there is nothing here for now, because I am just trying to make the variables, right? Okay, core syntax init. Lookup identifier. Lookup identifier is part of the scope. There should be scope lookup identifier name in the span, which is AST span. Lookup ident is not there. Oh, it's just scope lookup. So I just want to get to the situation where I try to refer to a variable here, right, like foo, and it should just say that Okay, it's trying to read the properties of undefined reading locals. Right now, I am missing the scope because I did not introduce a scope in the compiler. Let's see, how does that work? Compiler dot compile expression. This is done in the REPL, right? And but what I need to is I need to initialize the compiler state first, which includes initializing that, and yeah. So I need to say compiler init, and that's going to be compiler and state and scope, I guess, right? And then I need to say with compiler scope. Context being scope, and compiler context is compiler. I think something like that needs to be done. Alright, byte compiler init should return not just the compiler state, but also the scope. And the scope should be scope new, parent is none. Field context is not there. Compiler context, because I never said that there's a context here. Now I have. Field scope is not there. Compiler scope. I guess I just include the scope here directly. Like so. Okay, and it compiles, and does it work? Ooh. Yeah, there we go. So now we have a compiler error at REPL saying that we could not find foo in scope. It also quits the REPL, which it should not, so I should handle this properly. Right? Let's take a look at REPL. So when I evaluate, if this doesn't compile basically, or if the interpreter spits out the error, I should just not do anything, right? Which means that I need the diagnostic handler. Yeah, I just literally have the diagnostic handler for this entire scope. Which, if I handle the diagnostic, I should just print it, right? How do I print it? Diagnostic, is there just a printer? There's the default handler. But there is no such thing as print. maybe I can, yeah, how about I say this? Print is diagnostic, right? And this is going to be that. So I print it with the red color, that is the error over there, and there are some notes if needed. And so when I did the default handler, just prints the diagnostic and then exits with -1. I guess I should just rebuild from scratch, because this is what everything depends on. Alright, so now, if I go into the REPL and I say foo, then I cannot read properties of undefined, unwind on error. Why? Because there is no unwind on error. That's right, because we have a diagnostic handler context, but I should also have the diagnostic, the unwind handler. Right? Yeah. Yeah, because I don't really unwind on the parsing, so that was not needed. But over here, I should say that diagnostic unwindable handler, right, is unwind on error is just return, basically. A return from this function over here, from this block. And it should be without semicolon. Okay, once again, foo. Okay. Yeah, I guess I'm not printing it here, right? So I should say here diagnostic print the diagnostic, and that's it. That's how we handle the diagnostic. We just print it, and then we unwind by just stopping the evaluation of the specific line in the REPL. Alright, foo, compiler error, could not find foo in scope, and then we see this again, x is 1, 2, 3, right? There you go. And then we have the actual panic, because we have the pattern match that is not exhaustive, because let x 1, 2, 3 is not something that is implemented yet. So I can look up the things, but I never introduce the things into the scope, so that's the next thing. Or maybe like before doing that, I can say 1, 2, 3, right? And I want this to be evaluated, right? Because this is the simplest thing. Just to have a number. So yeah, I have the simple ASTs, which are empty. So empty evaluates to a unit. That already works, right? And then if I have the identifier, then we try to look up the identifier in the scope. And if it is not an identifier, but if it is a number is just stored in the tokens as the raw string, right? So this is the compiler, right? So I have the expected type. let's say what the type is, right? So type would be expected type, unwrap, or type. Have you looked at ATS code? No. ATS code. Roblox Anime Tactical Simulator. ATS lang. I guess I have been on this page before. Maybe you already told me about it before. Multi-paradigm functional imperative object-oriented concurrent modeler. It's ML with dependent types, it seems. C++, theory proving, and strict type checking. Detect and prove that there is no division by zero, memory leaks, buffer overflow, or other memory corruption. No. But sure. So you have something like refinement types here. And this looks like a dependent function, basically. Which exists in a lot of programming languages, I guess. UDC calls that return a proof by reference. Then you make other calls that use them. And you cannot drop a proof. And your loops have to be increasing or decreasing. UDC calls which return a proof by reference. What do you mean C calls? Is there any example of specifically a C call? There is no such thing in this code in the Wikipedia, I think. But I mean, that's how it is supposed to. But it's basically like, I don't know what specific kind of proof you are talking about. There's, so like, if you talk about C interop specifically, for example, right, then it should be something like the malloc is a function that returns a pointer, and we have proof that this pointer is valid, basically, right? So the malloc is not a function that just returns the pointer, but also the proof that the pointer is properly usable, right? Which would be the linear type. Yes, that makes sense. That's exactly how I plan to do this in Cast already. Yeah. You return the fact that some memory destination has some type too, which is really scuffed. It's an interesting idea. So, like, basically, do you even have a type system in such a language? Is it so like you instead of having a type system, you have proof that certain things have types? But yeah, in order to write proofs, you need a type system anyway, because that's what you write the proofs in. It's kind of both. It's an interesting idea. I don't know if I need that or not. Maybe it is needed sometimes. Basically, maybe it's needed to when you cast. You know what? It probably is needed when you cast to avoid star. Right? Because in order to cast avoid star to back to the original pointer, you need the proof that it points to the correct type. Yeah, it does make sense, because you do need sometimes to have the thing, and then you use the existential types to actually store the proof in the like alongside the thing, you know. Yeah, it does make sense. Actually, I don't think it's scuffed. I mean, maybe what I'm imagining is not how it's done in ATS, but that's... yeah. Is it not done like that? The C interop in languages like I don't know, Cork, Rock, Agda, or all of the other proof assistants? This one is specifically a low-level applied type system, a low-level proof assistant, which allows you to do the thing or something. It's mostly used for research, fewer than 200 repositories. Or is this like just a new one, so no one is using it yet? Coco is garbage collected, but you can, right? Like the language is garbage collected, but can you not have like proof for things? Coq still has linear types, I imagine. They're just optional. And this thing, in this thing, like everything is linear. Lean also is garbage collected, I think, right? Alright, unwrap or type dot int. How about that? So I'm going to have type int. Let's have the int type. Now, after I have the type, I'm going to match type shape. And if the type is an int, have you seen the video Rust and the Price of Ignoring Theory? No, I don't watch videos. I don't like watching videos. If there is an alternative of that in the form of an article, maybe written, then I would maybe take a look at it. I don't like watching YouTube. There was a time where I was like watching a bunch of talks from conferences, but have not been doing that in a while. Speaking about conferences, there is this thing called softwaremust.org, I think. Let's see. Is that the right one? Not sure. Let me see. Software should work. Not must work, but software should work. There we go. Independent conference on software reliability. And there is the creator of the Zig, creator of the Rock, creator of the SQLite, HTMX, author of Logic for Programmers, creator of PhilC. Data star, I don't know what that is. The summary is that they did not add GDT or dependent types like Idris, and you can make the ownership system incoherent. So it's not a good solution in long term, and we should focus on other approaches like Granule and Idris. The summary is that Rust did not add GADT, and you should add it. Yeah, I do agree with that. I think though, isn't GADT basically a specific form of a dependent type though, or is it not? Like, if you have a language with dependent types, do you need GADTs? Or are they just implementable? Kind of. I think it's a kind of a dependent type just, right? So like if you just have a dependent pair, then you don't need GADTs in a language. I think even like, even regular ADTs are not needed, technically. Because a regular algebraic data type is also just kind of a dependent type, because you can just say that it's a pair of the tag and the value, and the type of the value depends on the tag, basically, right? So you don't even, like... and then you control the memory representation of the ADT too. But yeah, maybe it still makes sense to have them as a primitive. I am going to have them for now, but like later when I want to have dependent types. And I want to be able to have all of these things, GADTs and everything. But I'm not sure like what is the set of the things that are needed to be like actually implemented as a language versus what things can just be living in a library, right? Because if we can trim something from the language, then it probably is worth making the language simpler. All right, over here, if it is not an int, I'm just going to say that number literal cannot be this type. Type print type, right? Like this. So now that I know that it is, I guess I need a value, right? And the value, which is, let's have a value shape. In this case, it's going to be a value, which is an int. And over here, I just need to parse this stuff. What do you think is the weakest valid definition for an allocation? What do you mean weakest? Let's say there is no syscalls or operating system. What's the weakest valid definition of allocation? Well, allocation doesn't need to be a syscall or operating system, right? You can have a static memory and allocate internally in your program, right? Like, let's say that you're implementing the operating system, right? That's what you would do yourself. The least amount of required work for a sequence of operations that we can call it an allocation. I mean, you just have an interface and you implement that interface, right? Now what's the interface of the allocator? I imagine the interface that they have in like Zig, for example, is good enough. Just make it more type safe, right? Like with the proofs and stuff. Call whatever libc does. No. I mean, let's see, what is there in Rust? Allocator. Is there a trait allocator in Rust? There is, right? So I don't know, this is maybe a little bit too much. For example, allocate 0, this is a provided method. This definitely is not needed, right? You just need to allocate and deallocate, and that's it. The grow zeroed by ref for some reason is here. Yeah, you just need to have allocate and you need to have the deallocate, right? Which needs yeah, I guess the layout. So what is the thing that we are allocating? And the layout has a size and a line, I guess. And that's it, yeah. If you're looking at some machine code, how, and not source code, how could you tell? Why do you need to tell? I'm not sure what you're looking for. Do you need to look at something and say that it's an allocation? I don't know. What's the definition of allocation then? Because I don't know. Like, let's say that you are initializing a list of integers, an array of integers, and you just make a loop from 0 to n, and then you put the value there. This technically could be seen as an allocation of an integer, where your array is the allocator, basically. Because what's the difference between that and something else? I don't know. The truth is there is no allocations. I mean, yeah, there is no allocations. If you are looking at machine code, there is no assembly instruction to allocate code, right? To allocate memory. In the end, you don't need to call into at least the kernel operating system with some definition of length in bytes and expect a pointer to somewhere? No, not necessarily, because you can like, let's say that you're writing C code, right? You can just implement your own allocator, something like, you know, basically you say like char memory, and over here you just create a static, like a static array with 1 gigabyte, for example, and you just implement your own allocator inside of the memory. Then you will not even be needing to create the kernel operating system, like no syscalls are going to be necessary. That would still count as allocation, right? That's literally what people do sometimes. Anyway, I don't know. Like, what's the question that you're trying to answer? What's the problem that you're solving, Ben? You know? You already answered? Okay. Alright, so I have type, which is int, and now I have also a value, which is an int. Of an int. I only have int32 in the bootstrap. Which, you know what? Let's say int. I'm just going to say that int is just int32. int x output write to string x. All right, so now that I have the value like this, the literal a number like this is going to basically be a constant, right? So I'm going to create a new expression, which is we need an expression which is a constant with the place. So I need to put this value into the place, right? So I need to place initialize with the value. Our salvation rests on our ability to know what the image base of a binary is. If we don't know that, then there is nothing we can know. So let's say on 64-bit system, 1 bit in a pointer is simply representing whether or not it is a physical virtual memory address. And the type. We just need the shape and we need the type, right? And this is a constant place, which means that I need to be able to initialize the places. Which we initialize with a value. So this would be ID is ID generate, state is occupied with a value, type is, I need to figure out the type of a value, right? Which is just a field here right now, so maybe that's all that I need. Right now I'm storing the type inside of the value. Field gen is not there in ID. Wait, really? Oh, it's ID new. I should call it gen. Alright, compiles. Now, if I say 1, 2, 3, it says unmatched value const. Alright, so this is the interpreter, right? So right now the interpreter can only evaluate the unit expressions, but now I should be also be able to evaluate the constant expression, which evaluates to a place, right? Yeah. So I just need to be able to read place. That will give me a value. Read place. This should give me a value. I'm going to match place state. If it is uninitialized, then we're going to return the error. If it's moved out, must be moved out, and if it is occupied with a value, then I just return the value. So the error means that in the diagnostic, interpreter error. I just tried the string s, I guess. Couldn't find span. Yeah, when I read the place, I need the span for error reporting. Span is expression span. Interpreter. Diagnostic output span. Maybe something else will be needed. Source is not interpreter. Okay, I guess diagnostic does not support the interpreter as the source. Alright, and then this should be a reference. Alright, it compiles. Is it going to work? Can I actually do 2 now? There we go. So now we have the interpreter, which can evaluate numbers, which I give it like this. Alright. I don't report errors if we have the overflow and parsing. It's okay. Well, I mean, this is backed by JavaScript right now, so just rounds it. That's fine. Okay, so the next step would be to implement something like 2 plus 2, right? Or maybe like variables. I was working on variables. How about I say something like let x be 2, and then I say x, right? After that. Okay, so I need to implement some of the core of the syntax, right? So right now, this over here, we had a semicolon, which is the core statement syntax. Okay, so the way I do that is I have the core syntax over here. And in the core syntax, I have a map. like this. And if my AST is not a single token, but actually a complex rule node. Let's see, AST. So I have the rule node. I have the rule there, and then the root, right? Rule, root. So, I say that if rule name string strip prefix. Am I still working on Linksider? No, not really. I have not worked on it in a long time. But I will, eventually. I'm thinking that maybe I'm getting somewhere with Cast. If I keep not working on Linksider for like another year, then I can see rewriting Linksider in Cast. And then my first game on Steam would be written in my own programming language. That would be cool, right? Maybe. I don't think it's that difficult to rewrite it from scratch. If the language was ready. I strip prefix core, and if this is some core syntax name, right? So in this case, I need to find the core syntax of the current compiler. State core syntax. Map get core syntax name, right? So I'm just going to now say match this. And if it is none, then I'm going to report the error. And if it is some, I guess over here I'm also going to match, actually. So in this case, this is a custom syntax, not the core syntax, which let's say that I just don't panic to do custom syntax, right? In this case, it is not found, so I'm going to report the error. Core syntax not found. Escape the string core syntax name. So if it is some core syntax, then I'm going to do something with it. And what is the core syntax? It is a thing which has a name and compile function, right? And compile function should compile something that is compilable. I don't have the trade bounds yet, but yeah. Because I can compile an expression, a pattern, a place expression, a type expression, and a sign expression. This says compile any expression also. Wait, hold on. This says compile any expression. I guess this should be any expression. Expression, yes. Well, a regular expression, I guess I just call it a value expression. In C, it's an L value versus R value. Or is it in C++? I don't know if C also has this concept of L values. But it probably does, right? In C language, yeah. Core syntax. So just say core syntax compile purple link else gamer, yeah. So I just say compile, and I'm going to compile any expression. AST is wait, why does it take an AST? This is the core syntax. It should not take the AST. It should just take the root actually. Root, I think, which is a reference to AST group, maybe, right? Yeah. I keep it like the original AST so I know like the other things. So I can print it easily, I guess, if needed. So I compile any expression in this case with, I say AST, I say root, and I say expected type. And that's what I return. So right now, I need to strip prefix. Prefix is this, because this is a named argument apparently, sure. Any expression is not unit. Yeah, semicolon should be removed from here. I can get rid of this too. I don't know if I should. Something like that. Get rid of one more indentation. Okay, this compiles. So now if I say cast, and if I say 2 plus 2, it will say to do custom syntax, because plus is actually a custom syntax implemented through a macro. But if I say let x be 1 to 3, then it's going to say core syntax not found assign, right? Because this is the assignment operator to the new variable x. All right. That makes sense. Okay. Well, let's implement that syntax, right? I'm just trying to not have like a single huge file like I had before with all the syntax in it. So like over here, I want to say add to the map the sign. I guess I can just import actually. I can just import sign like that. I can have every syntax in its own file. Maybe it's going to make it easier like that. So I can say add is map and then so just going to say map word map add item name item. That's all. It does mean though that I want this. To be here. And then we have the assign. So the assign syntax is something like this, right? I just import the common stuff here, and then so it's not a module, right? I literally just have the as a result of this file that I'm importing is the core syntax itself, right? So this should be a core syntax T. I can like, yeah, but I need it to be over here. Super core syntax. A little ugly, but okay. Which means that this is going to be called core syntax, basically. So name is assign and compile KST root expected type Okay, so since I want to assign, I mean, this should return K. Which is supposed to be, so like I cannot do it as a pattern, right? How do I write that code here? This was done with the GADTs in my Bootstrap in the OCaml, where, yeah. I would be able to match on this. Like I want something like K as compile assign. Compile. It's the root expected type. Compile assign is a thing. Self. And compile is now just returns self. And then I can implement any expression as compile assign. I don't know. I mean, this should work, but I mean, I guess that's how I would write it in, like, Rust, maybe. The only issue is that I'm not, like, checking. It's actually checked at runtime that the trait is implemented. So when I say compile, like this. So now I know that it's an any expression that I need. So assignment would be just a regular expression, which is a statement, which means that the return type is going to be a unit, right? And it's going to be an expression. Hello, Douglas Upity. It's the assign expression. I need to know the assignee and the value. What does it mean for a language to be self-hosted? It means writing the language in itself. So this on the screen right now is my language, and I'm trying to write it in itself. It is originally written in OCaml. And it is transpiled to JavaScript at the moment. And then the plan is to self-host and change the backend from JavaScript to C. But to write it in itself, you first need to write a compiler for it in another language. Yes. But it's a transpiler. Which I think makes it a little easier than writing a proper compiler. I also have an interpreter. So what I'm starting with here is the interpreter on the self-hosted version too. Technically, you don't even need a compiler. Like, it could be only an interpreter, I guess. Is there any interpreted language that's written in itself? I mean, there is Python implemented in Python, right? Like the PyPy. Technically, is the implementation of Python in Python. And it's also faster than the CPython, if I understand correctly, because of the JIT. All right, so what's the assignee expression? That's a different kind of an expression. So I have place expressions, regular expressions, and we will also have the assignee expressions, which I guess those are different enough. We'll have assignee expression, which has shape, span, and type. So in this case, I should assign... Actually, it's interesting because it's going to be an assignee to a pattern, which means that I need the patterns already, right? And then I have a pattern. And a pattern is a binding. That's the let x on the left side of the assignment. Expression assignee pattern. All right, so I have the root. Here is the definition of the syntax of the core assign, right? It's just assignee equals value. So I need to say that I have AST helpers. Let me import that. AST helpers. I'm just going to keep it there for now. That's part of minicast. So I just need to say that assignee and value is root AST helpers expect two children named assignee and value. Oh, this takes the thing by ownership. Sure. Can find self. Right, so this self is any expression. Any expression. Expression is not a sign. Right, so I need to have a new expression, which is an assign expression, which has assignee, which is assignee I guess I don't even call it assignee expression. I literally call it assignee, I think. Just assignee. And then the value is... The value... Should the value actually be an expression? Or should it be a place expression? I think it should be a place expression, actually. Yeah, and assignee is not AST. So this is an AST, this is an AST. So now I need to convert the assignee to an AST, which means that I need to compile. And to compile in this case, I need to compile an assignee. So this takes an AST to compile, and the expected type of the assignee, we don't know what it is actually, but this is the assignee, right? So I should say assignee is that, and then the value after I compile the assignee. So I handle the left hand side first. The assignee is compiled. Now I should know the type of it, and I can compile the place expression of the value with expected type being the assignee type. Yeah, that makes sense. So now it doesn't know what compile is. Compile should just be in the common over here somewhere. I should say compile is KST and expected type, optional type, and this should return K, and this should be the compiler context, basically. Compiler context. Which knows how to compile. And this is a different context, right? Compiler state context is different. So this should also return the state compiler context D. So this is just a form of the dependency injection, because we have the compile function which depends on the things which depend on the compile function. Compile is, so in this case compile should just be defined in this scope. And yeah, and this is where we do k as compilable, compile AST expected type. This goes through so many indirections. Compilable is, so this is very similar to what I did here, but it's a more general purpose. No root, so this is just compilable. It just compiles into self, and then I should implement compilable. Implement any expression as compilable. Compile is compile any expression. Then we have implement expression as compilable. Let's compile expression. Compile place expression. I will also need assignee and pattern, and we will have a type expression later too. Alright, and this is where I also need to copy that, I suppose. Compile assignee. This should return an assignee. Maybe a GADT would be easier, but I don't have them. In case I have a rule, this should be like the same code. It's in these cases that it is a different thing, right? Yeah, I think actually, you know what? What I should say is, when I want to compile an AST as this compilable thing, what I'm doing is I am seeing if it's empty. So in this case, I should say that this should be k as compilable dot unit. So compilable should be able to be a unit. And then I should be able to do the identifier. So in this case, this would be k as compilable identifier, name span, identifier is string span itself. So when I say any expression, identifier should be expression. This is just scope lookup, which I can just say that identifier is scope lookup, literally. And then a number. This should be a number. Okay, as compilable number. Number is a function from token number. And then in the rule, this is where I just compile K, so I forward it there. Yeah, that makes sense. I think, maybe. So I don't say compile. I need to implement for every type of an expression. How should I treat a number, identifier, or unit, right? So just the primitives, not the custom syntaxes. That makes sense. So unit here is just a function that returns. Shape is expression unit. Type is type unit. Identifier is scope lookup. And that's it. Okay. Expression and end place expression should basically be based on any expression. So I say unit is yeah, I guess I just need to say any expression to place expression. And then I need any expression to expression. Which does that. So unit is a function that returns any expression to expression. Any expression as compilable unit. Unit number and identifier. And same goes for the place expression. I just say to place expression instead. Okay, now assignee and pattern, those are different. Completely, right? So unit is Let's just do panic for now. To do unit assignee. To do unit pattern. Number. So I should not be able to assign to a number, right? I should not be able to say let one be something. So I just report here. I just report here, cannot assign to a number. Patterns. Number patterns should be available, but that is not implemented in the Bootstrap even. It's basically a constant. Pattern. Okay, and then identifier means that I should be able to assign to a thing, which means that actually lookup. Why is lookup returning any expression? I think it should not return any expression. This should literally return a local. I think scope local is literally something that should be returned here, right? So they should return local. And I should implement that thing over here. So I have name. So I say local is lookup name in the span, and then I match it. So local can be a binding on a const, but if I want to assign, but then I should only be able to assign to a runtime variable, not to a constant. So identifier name span. So I should also just look up in the current scope the name, right? Hello, George Orbad. So I'm going to match local. If it is a binding, then I'm going to do something, but if it's a const, then I should report the error, saying that I cannot assign to a constant. And now if it's a binding, then this should be an assignee. This should be an assignee, right? So here's my assignees. It has pattern, but it should also be an assignee. So pattern introduces the new variables, but I should also be able to assign to existing variables, which is just assigning to an existing place, right? So just a place. So in this case, oh, I mean, no, should be a place. No, not a place. A binding is what I should assign it to, right? Because binding is a runtime reference to a place. Yes. Okay. So this should be shape is binding. Type is binding type. Okay, and then pattern. If I have a pattern, which is an identifier, name span. So this is actually introducing a new variable, right? So this is where the new binding gets created. Pattern over here, binding. But what's the type? What is the type in this case? So in this case, I need to know the type here already. So identifier is something that should have the expected type actually already. And the number also should have the expected type, by the way. So in this case, the type must be here, right? So type is match expected match expected type. If it is some type, then type. If it's none, then I need to report an error. So I'm trying to do a different algorithm for inferring this time, which is actually not doing unification. It's supposed to be simpler to implement, but more annotations might be required. Failed to infer binding type. Let's do that. That's my type. Now I know the binding. And what is the binding? This thing has the type. It has ID. Is there anything else in the binding? Actually, there is nothing else. Right now. Compiler dot compile. Compile K. Field compile is not there. Compile. Named. Field label must be ident. Compiler field label must be identifier. Oh, an equal. Implement pattern is compilable. Underscore span expected type is not. Span expected type is not unit. When compiling the pattern. Why? Span expected type. Span expected type. Unit number identifier. Oh, it's probably the number. No, this number also has expected type. So everything is fine. I guess this number. Yeah, that makes sense. Alright, so now we have a name span and just expected type. Yes, and same goes for the number. Expected type should be passed through. And now local is not that. Local is not... Yes, because this should not be scope lookup, right? This is what? This is compiling any expression. And this is what I need, right? I just need a scope local to any expression. There we go. Scope local to any expression is local is a reference to scope local. This should return any expression. And I just match the local. Like that. Wait, what? No. I copied it from the incorrect place. That's an assignee. I needed to get the one from the any expression, this one. Scope local to any expression local. There we go. So over here, if I want to compile any expression... Oh wait, but compiling expression is not something that I even need. Because... Yeah. This is already copy-pasted code. So compile any expression is not even a thing that I should have. Could not find span. Any expression to place expression. Span is the extra thing because any expression does not contain that. Token is not in scope. A number is not there. Number token. Number token is that. Token dot number token. Sure, whatever. Okay, and then over here I say this any expression to expression. Yeah, I still need this pen here, I guess. So when I say the unit, I need to give it a span. Any expression dot units. Span everywhere. Okay. Span is arc span. Alright, what is this? Shape and type. Binding is not assignee. Alright, because for the assignee I actually need to initialize the span. So for the assignee, I need shape, I need type, and I do need this span. Same goes for pattern. Pattern is to initialize shape, type, and span. Binding or pattern is not assignee shape. Wait, what? Binding or pattern is not assignee shape. Literally binding or pattern. Okay. Oh, because I see. I see the problem. ID. Couldn't find ID in scope. This should import ID. Okay, now what? Compiler init returns compiler state, and so this is going to be compiler state. Compiler context is compiler state, and no, compiler state context is compiler state. It's a little weird. State context. Is it not state context? What did I call it? State CTX. Let's not do CTX, let's do context. I think first is broken. Well, I guess it's not here. Maybe it is. So instead of saying compile expression, we actually say compile expression, like this. Right? Yeah. This should be like high level intermediate representation expression, which is not in scope. Oh, I just imported. Yeah, it's literally just expression then. All right. Hello, Nigel, though. So I basically am rewriting the cast from scratch in itself. So we are back here in the REPL. I can press enter. This evaluates to unit. I can do 1, 2, 3. This evaluates to 1, 2, 3. And if I say 2 plus 2, it will say that to do custom syntax, no minicast. We'll see if I actually need the minicast, but yeah. I think I will reuse a lot of the code that I have in the minicast, but I like architecturally, minicast is very different. I think I will just keep the transpiler to C from minicast, because that's going to be very similar. But the compiler itself is just architecturally different, because it is supposed to be an interpreter, but minicast was like completely different. So yeah, instead of upgrading minicast to cast, I actually rewrite it from scratch. Whether I still use the minicast as the intermediate language, I think also the answer is no, because instead of like using the intermediate language, I literally want just to be able to convert the language in like there still is going to be like maybe something that is like minicast kind of, but it's going to be literally a subset of the language, not a separate language, which is not going to be implemented separately. But literally, just like, let's say that, like right now, I can assign to any assignees, right? But in minicast, I can only assign to a single variable, right? So I cannot do like a destructuring. So but what we can do is we can rewrite the existing expressions which use destructuring to the things which don't, right? To make it more lower level. And like convert pattern matching into like a bunch of ifs, for example, or whatever. And yeah, but it's still going to be like in the same thing, and that's what we're going to call minicast instead, I think. All right, what was I implementing? I should say like let x be 1, 2, 3. No core syntax is found, right? X could not find exit scope. X is 1, 2, 3. No cast impl found, actually. Okay. Yeah, because expression as function. Wait, what is this? Expression as something. Oh, because I need it as compile assign, right? Okay, I think. Any expression to place expression. I think these things can go into the common over here. So yeah, what I need is I need to implement. Wait, do I literally implement any expression as compile assign twice here? Lol. I just have copy pasted code here. All right, I need to implement expression as compile assign as compile is args into any expression to expression, any expression as compile assign compile args span is args span. So an expression, and I need a place expression. Actually, you know what? So in original cast, I could assign. Like I can throw a compiler error if I'm trying to compile an assignment as a place expression, is what I mean. I don't know. Let's not do it for now. So this is actually supposed to implement this for everything. Right, so we have expression, place expression. We have can I just have this as a macro? Line 45 looks new. Line 45. This thing? It's just a type annotation, which is before the thing instead of the after. It's a prefix type annotation. Instead of saying that expression is having the type, you can literally just say type expression. That's it. All right, let's do it without the macro first. It's just, this is going to be a very repetitive thing to do. So we'll do pattern as compile assign. That's going to return the error. Diagnostic. That assignment cannot be a pattern. Assignment cannot be an assignee itself, so should not assign to an assignment. Doesn't Haskell have something similar? I don't know. I don't know if Haskell has something similar. It does look kind of similar to like casting in C, maybe, or like a compound. Initializer or something. +1. Yeah, I guess it does general purpose like that. I don't think in Haskell you can do in parentheses the type ascription though, like that. You can just partially apply operators, but this is not a real operator. I think in Haskell maybe. I mean, you can try to see if it works like that, but yeah, you can partially apply an operator and it turns it into a function which has the missing argument as the thing. Not sure if I am a big fan of that feature. It's okay, I guess, but can also be weird. Like if you say +1, how do I, like, if I say -1, how do I differentiate between the binary operator -1, which is missing the thing, and the lambda x x -1, right? Or like it means either this or it means literally just -1 as a constant, right? So which one is it in this case? I am not actually sure what it means in Haskell in that case. Probably a constant, right? So we have assignee, we have pattern, expression, place expression. I will have a type expression later. Could not find scope. Scope local to any expression. Let's just say have local to any expression. Scope. I mean, maybe if local to any expression is only used here, I will actually... Yeah. I'm actually going to go back to have this in line. Field span is not there. Oh, right. Because now I have the AST. So it's arg.0.span then. And this thing should be also dereferenced. So this doesn't have the span, right? It has like AST. And span is AST span. All right. Am I making progress here? 2 is equal to 2. This should say that I cannot assign to a number, so this is nice. Okay, if I say x is equal to 2, it will say that could not find x in scope. Okay. Right. And if I say let x be equal to, it will say that core syntax is not found let, right? So now, if I have an assignee, which is a let, this is the core let syntax. So let's copy the assign into a let. I'm going to add the let core syntax. So this should be compile let. So I guess let cannot be. At this point, I want the macros. So there is a lot of like syntax which is just an expression, right? So in this case, I return an expression. But I think, yeah, I think I basically want to have the function compile assign, and this is going to be this function. and then I implement that by saying implement any expression syntax. This is a macro which is going to be implemented using compile assign, and the trait is compile assign, I guess. Something like that. So then I say implement any expression syntax. I don't support really the pattern matching on this though. How do I get the arguments? No, I can just say include AST. Include AST, implement any expression syntax like this. There we go. I can do that, yeah? Yeah, so I can do implement an expression syntax, and this would be yeah. So this needs a function. So this needs compile function, which is having this type, which returns any expression. And it also needs the compile trait, which is t type type, right? Because it's a higher kinded type. I cannot do it like this. No, this one must be an AST, I think. And this is not the AST that I'm doing. This is the std AST, which I'm going to quote here, I suppose, for that to work. And this is the function that's going to return the std AST, which is going to be just a quoted thing. So I need to implement any expression as compile trait as compile this compile function, right? And then I implement expression, I implement place expression. And those are done like that. And then I say pattern and assignee. Should be done like that. Which means that also I should give it the... so I should give it the name. So this is assignment, so that I can write that, right? So this is name string, say output write name, cannot be an assignee. Output write name cannot be a pattern. Okay. And then this thing can go into the common of the core syntax. And this is not compile assign, this is compile trait. Okay, seems like it works. Nice. So now, a let is specifically just only a pattern. So there are a lot of syntaxes which are just expressions, like I did here. But there are also a lot of syntaxes which are just pattern. So this pattern syntax. I'm going to say name, compile function returns a pattern. Or, I don't know, maybe there's going to be also only an assignee syntax too. So in this case, I'm going to be reporting the errors that this cannot be an expression, right? It cannot be expression like that. Like that. It cannot be an assignee, but it can be a pattern. In this case, compile is just compile fn. Right? So that's the pattern syntax. But then I also implement the dedicated assignee only syntax. Maybe, where I say that it cannot be a pattern. But it instead can be an assignee. I could do it with less copy pasta, but it's fine. I think let. Okay, so yeah, there we go. I have very important day. Brainoid has been a moderator for 1 year. I didn't even know that this is a thing that Twitch has, where you can celebrate your moderators. Okay, so we have compile that. Wait, what? Why do I even have a trait like this? Oh no, it's yeah, I know why. I know why. I think this should be a new trait every time, though. Shouldn't it? Oh, I think it should. So I just implement any syntax. I just say assign this, and this is the result, and this is that, and this is going to be part of the macro too. So there is no such thing as compile trait, actually. I just give it the name and then the function of the correct type, right? So there is no compile trait. I'm just going to say compile trait, which is going to be compile trait, like that. And this is the result, and the name is the name that I have, and then this is the compile. All right. It's a little weird. Okay, I still have the copy pasta in this macros, but at least no copy pasta outside of it, I guess. Could reduce this further. There's no compile trait. There is no compile trait. Any expression syntax? Also no compile trait. Congratulations, you had to get a car from Kuviman in 3 days. Alright, right after I get the car from George, I'll pass it over to Brainoid. Let x be 1 to 3. No cast impl found expression. Yeah. So now over here in the let, right, we instead, similarly to assign, right, so now this is pretty small, right, I do similarly to the let, so there's going to be a let syntax, and this is compile let, and compile let is going to compile into a pattern, no, into an assignee, and a let is a syntax which just has the pattern as a single child, expect single child named pattern, right? So I say that pattern is this, and then I say that pattern is, I'm going to compile that as a pattern. Expected type is the expected type of the assignee. And then I just say that I have an assignee with the shape of being pattern. Or I guess maybe the shape should be let. I should literally call it let, right? Maybe that's what I call it already. So it's I either assign to a binding or I create new bindings with a let. So I say that I let, no, not here, in the let. I say that I let pattern, where the type would be the pattern type. And span is AST span. And this is the let, right? Okay, that's pretty small. Does that compile? It does not. I might need to update this file. Alright, what does it say? Any expression is not assignee. Yeah, because I need to implement not any expression syntax, but assignee syntax. And assignee syntax in the common. Compile assignee syntax. This should return an assignee, not a pattern. And then it compiles. Okay, and now I think what's missing is the interpreter, actually. So now if I say, let x be 1 to 3... Oh, it's going to say fail to infer binding type, right? Because I'm not saying the type of it, but I'm trying to compile this, right? So what's the type? I need to know the type. But I don't. I'm going to require... Yeah. Like, on one hand, I want the expected type to also be determined based on this. And then sometimes it's in the other direction. How does it work in the other languages with bidirectional type checking? Maybe they do the syntax differently. Like, this is a dedicated syntax. Is it a custom compiler? Yeah. Well, I mean, what do you mean a custom compiler? It's a custom programming language. Which is including a custom compiler being the transpiler at the moment. And then we also have the interpreter. But the way interpreter works is that I compile the thing first before interpreting it into a high-level intermediate representation. Which is why, in order to evaluate this in a REPL, I need to first compile it, which needs to be type checked. Okay, I think what I need is to implement the type annotation, basically. So cast, let's see, I say like let x int be 1, 2, 3, right? That's what I want. So now we have course index which is not found, which is type ascribe. Type ascribe is a special syntax, I guess. Or maybe not too special. Let's see, type ascribe. So type ascribe is just a syntax. Name is, so this should be for syntax, right? Name is type ascribe. Compile. Is compile. So the expected type in, so basically what we do, but if I do type ascription, then I need to already have the type expressions implemented, right? Okay, so in this case, what I need is syntax ks type ascribe. Type ascribe is expression type. So I say that expression and type is root est helpers expect 2 children named expression and type. And then I say that type is, so type in this case is a type expression which needs to be evaluated into a type, right? So basically I should say compile a type expression type well, expected type of the type expression is always going to be a type, of course. Let's just say compile type. I mean, should it even be a compile? Let's say like evaluate type. I mean, yeah, no, I should still have like a type expression too. Compile type expression type. And then I say that type is evaluate type. Type, right? So now that I have the type, I'm just going to compile. I'm just going to now compile the actual expression with the expected type being the type that I have now. Oh, sorry. So I add the type ascribe. So what is compile a type expression? What does it mean to compile a type expression? Compile type expression. This just has the ASD. And this should return a type expression, which means that I should have a new thing called a type expression. Similarly to a place expression, I'm going to have type expression. Did I call it type or tie? Tie expression? Sure. Oh my god. And then the type expression could be just a regular expression which evaluates to a type, which is all that I'm going to have for now, because we are going to refer to a compile time known variable called int, which evaluates to a type. So we should have types as values too already. The type of a type expression is going to be always a type, but I don't know, like technically it does not need to be here, I guess. So when I compile a type expression, I should just say, this is basically compile a type expression where expected type is some type. So I should have a new type, a type of a type, which is a type, right? And then what is eval type? Now, eval type is something that is part of the interpreter. So the compiler actually depends on the interpreter. The interpreter depends only on the output of the compiler, not on the compiler itself. So here's my interpreter. I should be able to have evaluate type, which has the expression, which is a type expression, and this should return a type. So right now, the only type expression that I have is an expression, in which case, what I need to do is I need to evaluate this as a regular expression, right? But this value must be a type now, which also means that I need to have values, which are types. And this should be type, print type. I guess I just say interpreter eval type, and I'm going to import the interpreter here. Okay, but when I evaluate the type, so this should be a value. So when I evaluate an expression, this must evaluate to a type, right? So I'm going to match value shape, and if this is a type, then this is my result, and in the other case I need to report an error, right? I say expected, or I should say something like maybe just evaluate expression, expect unit. Is there such a thing? Expect int. I don't have that. So this value fine, let's just have this in the interpreter. Expect expect value type. How about that? At the span to expect value type is, so I have the how about this? I just say expect value to be of type name is type. No, I don't think that works. Maybe with a macro I could do that. Implement expect value, name, and type, and tag. That could be AST, I guess. Maybe that makes sense. So I could say that expect value type is implement expect value include AST, implement expect value type something like that. Maybe. So this is just a function taking value and returning the type and also span, and this is just going to match value shape. And if this is the tag, then, and if it is the tag result, then I just return the result. And if it is anything else, then I report the diagnostics. The diagnostic being expected. And then I write the name. Right? But then I say got. And then I print the value type. Sure. That's not bad. But what? There we go. Lib tie is not type. Tie is not type. Type is the different thing, yes. Why are you complaining though? My error messages are bad. Let's try to recompile from scratch, maybe. It is the same error. So what's the problem? Tie is not type. Expect value. Oh, right. This is not a type. This is actually needs to be an STD type, right? Because I'm passing the type, right? This is what I want. I don't want the value of the type that I'm implementing. It's a little confusing when I have like multiple things called type, I suppose. All right, so now when I evaluate this should just not have the semicolon. Okay. What is this? I failed while transpiling something. I have not seen this error in a while. What's the problem? While doing this, while doing this, while doing that. Oh, I have something not implemented in the transpiler. What is it? I'm transpiling the value shape REPL. I'm transpiling value shape type ascribe, right? I'm trying to transpile the type ascribe. So I'm trying to transpile this thing in the interpreter. Oh, yeah, that's right. That's right. It's because I have a function, and this function is supposed to be used only at compile time. So because it's supposed to be used only at compile time, I actually need to CFG here and say that if target name is interpreter, only then I can do that, because I cannot do a macro at runtime. And in other cases, I'm just going to panic, saying macro runtime only, please. Like that. There probably should be something which... no, it shouldn't. I just should not even try to compile things which are not used. But that's for later. Compilation failed. Cannot await function to be compiled. Wait, what? This one over here? Because I'm inside of a module. Oh no. I cannot have the macro invoked immediately inside of a module. That's also the limitation of the current implementation, I think. Maybe? I'm not actually sure. I mean, yes, in this case it is, I guess, because this... yeah, it's a little weird. I can have that to be implemented outside over here somewhere. Probably. Yeah. So the problem is that the module introduces the recursive scope. Include AST is something that needs to be evaluated immediately at compile time. But in order to evaluate this immediately at compile time, I need to like resolve the symbols, which cannot be done immediately until I parse until the end of the module of the recursive structure. So that's like the reasoning here. Oh, but I guess I can have this here and that there, though. Yeah, you know what? And this also should be done inside of the common. Also, if I do this, then maybe it will work, because it will be compiled. No, it cannot. This also is a little bit weird. Because I need to import things first, then implement this function, and then re-export. So I'm inside of a module here already. I guess I can like import this twice. Then it will work. To do this is imported twice because of macro needs to be compiled outside the module, but it uses the dependencies. Okay, cast. Hello. Hello is 2. Let x be 1 to 3. Fail to infer binding type. Okay, so now if I say let x int is equal to 1 to 3, no, this is going to say error null cast impl found because I wanted the type expression as yes. That makes sense. So now in the compiler, the last type of the expression is of the compilable is the type expression. So I need to have type expression. I guess it should be closer to the other expressions because it also is an expression. To do number type expression. I mean, it's probably similar to the any expressions actually. So it should be any expression to type expression then. Let's have an expression to type expression. Should I? Actually, no, I should not. No, this is a little different. This is a little different. This is a little different. I have type expression as compilable. Okay, similar to pattern after all. Type expression. To do unit type expression. Unit type expression is the unit type, but let's have it as a to-do for now. To do number type expression, or maybe in this case actually a diagnostic. Number is not expected, a type got number literal. Identifier. So now if we have the identifier, right? If this is a type expression, if this is a type expression, this is actually going to be very similar to this. So I'm going to look up the name in the scope. It must be available. If it's a constant, then I should read that place, and this is the value, or and then the type is, the value that must be a type. Right? So this must be evaluated to a type. Or rather, if it's a const, like technically, an identifier is literally, you know what? This should just be expression is, I should just have expression as compilable. Identifier with the args, right? And then I say if expression type is this expression type shape is type, then I do that, then I just return the type expression, which is an expression with the span. Sure. And if not, then I'm going to report an error. Right? Well, the error would be that I expect it to be of a concrete type. Right? Let's just say this, expect, or maybe like type check. Maybe I should type check expression I think we just need to implement the type check in here, right? Where the expected type is the type, and the actual type. We expect actually some type, but we got this. This is like actual. Is this, expected is that. And now that I know that it is type checked, we do that. Okay. So now let's say that I have a type check. We have actual, which is a type. We have expected, which is an optional type. No, let's do type. I will have like a maybe type check with expected being optional later. So this is where I just need to pattern match actual shape and expected shape. If it is unit, then it's okay. If it is unit anything else, then fail anything and unit is fail. All right, so we have units, we have ints, we have types. Those are the only things that I have for now. Fail is just a function which says that I report the error, right? I just say expected. I think type checking should be in a dedicated thing. Let's have a type check. Can I do that? Because I think it's a little Um, it's going to be the impl. And then I also have the actual type check. Because this is going to not report the diagnostic immediately. Because that is like the inner type that is failing to type check, right? So I'm going to have a new thing. Const type check context. So I am basically failing the type check context because I'm going to have these related informations, I guess. Or is it not related? It's not like really related, it's just a more detailed message. Maybe. So fail just has actual is type and expected is type, right? And this would just be current type check context fail actual expected. So the type check is going to call the type check impl, but I will need to set up the type check context. And when I fail this, we also fail the global type check. So I know both the inner and the outer type. Are they the same? I don't know if they are the same. But I guess I could also... I guess I could also say... with type check context being... so that I don't report the error twice or something. Actually, never mind. Yeah, you know what? It should be not fail, but it should be like failing with the message, you know? And the message is just a function which writes to the output. So fail over here, this is the message, which is just going to be written over here. Yeah, maybe. I could say output, right? No, let's just do the message directly without any extra information. But over here, I could... yeah, not here. Like whenever I go into the deeper things, I could say that like specific field differs or whatever. Or no, wait, what? Fail. Like in this case, I actually don't have any extra message, right? Yeah, in this case, I just don't have any extra message. In a lot of these. So this would be just current type check context fail with no extra message. Right? Wait, no. The message actually... No. The message should be here. The message should be that the... expected type print expected. And then got the actual. That's my message. Right. Function type cannot be expression. It's a type. Could not find fail in scope. Context. New type. And this should not be named even. Can find span. Yeah, what's the span? When I'm doing the type checking, I should have the span, right? Available to me. Yeah, so over here I'm doing the type checking. I need to give it the span. And this is not sum, this is literally just a type. Could not find span in scope. Yeah, because span is... Alright, let's just say span. It's rx.span. Alright, it's a little bit complicated, but that's how it works, because we have the compile time evaluation. That's the whole reason for the interpreter. So when I say things like let x be an int is 1 to 3, what happens is there's multiple parts here. This is an assignment expression where on the left hand side I have the assignee, which is a pattern, which is let x, type ascribed with an int. Now this int over here is also an expression which is evaluated at compile time. It, in this case, is a very simple one, but it can be a complex expression, including the runtime variables, runtime being the compile time. So, like in case of a generics like this, for example, right, I have, this is a generic, so this over here is a type, and this over here is a function type, which is returning self, but self is an argument here, so something like that. It's yeah, it's a little weird, maybe. Right, so I need to evaluate this as an expression, right? Right now I expect to see the error, which is going to say that int is not found in the scope because I never defined what an int is. Yes, and that's what we have. So I don't know what an int is, and an int should be a thing which is... Okay, well, technically, this should be defined in the standard library and exported through the prelude, which I don't have yet. So we should have, though, how do we define it in the standard library, right? how do we define something that is known to the compiler? And for that reason, we have the thing which is called a native expression. So I should say native int. And this is how we talk to the interpreter to retrieve the value known to the interpreter. So instead of saying actually let x be an int, I will say let x be an native int. Or I guess first, before that, I will say something like const int is native int. That's how we define what an int is. So that makes this be available at compile time now. If I implement the const, right? Which means that I should have natives in the interpreter. And I should have a native expression. So there is a new expression type, which is called native. I can for now just say string and like don't support interpolations. I'm supposed to have the interpolations later though, too. I can also kind of like hard code this for now. I can also kind of hard code this for now in the compiler. How about this? How about this? How about if I say that if name is equal to int, then this is going to be a to-do. You know, this is just temporary. Because this is enough progress, I guess. If it's an int, then this is going to be actually, let's return then here. Let's return a new expression, which is a constant, which is place initialize with the value being the type, the type of it is the type, so type is type, right? And value is type int type. That's what I have for now. Right? So now in the interpreter I can actually just evaluate int. Int is an int. That's a type int. I should probably also say that when I am printing a value, if I am printing a value and it's a type, I should actually, before printing the type, I should write type, right? And when I print the value, I could also say colon and type print value type. So that I can have more information in my REPL. So if I say int, then it is not an int. I did not recompile it properly. And to fix my recompilation with the includes. Let's see, so int, yeah, there we go. Int is a type int of type, right? Okay, and then like 0 is 0 of type int, and nothing is unit of type unit. Right? That makes sense. So if I say let x be int is equal to 1 to 3, then I have actually successfully compiled this, and now the interpreter does not implement the assigning, because that's an expression that should be here. Which means that I will need to implement the interpreter scopes too and stuff. Yeah. Okay. There are more things to do. Even for the simplest things, but we'll get there. This is good progress. This is a huge commit already. Git diff stat 77 insertions, 44 deletions. Not that much, I guess. Oh wait, no, there's a lot. Oh, just new files. I guess it doesn't count the new files. It's only only like the changes actually. Unless I maybe if I did say git add, then the stats are. Yeah, there you go, 1,000 insertions. That's more like it. Okay. Beginning of self-hosted interpreter. It's here. So I cannot do much. I mean, I can compile it though, right? I can compile it, I just then cannot evaluate the code yet, which is introducing variables. Yeah. All right. Good enough progress. I'm going to go rest. Or not rest, I have some other things to do. Learn you a Haskell challenge. Sure.
Let's just read one more from 0.
Haskell sounds interesting. Let's see someone struggle with it. Alright, see you guys next time. Thank you for watching. Bye.